Okay, so here we are in the next section, problem numbers 23 through 28. Okay, and we're going to do all the evens like we've been doing. Now this is where we get a little bit, we need to get a little bit, I don't know, creative would be the word, but the concept of when x is approaching positive or negative infinity allows us to just focus on the terms that are significant. So if we look at this one, we can see that this plus 1 here, when you send x toward negative infinity, this term right here, 3x squared, is going to grow beyond bound, but this guy here, adding 1 to infinity, is just, like I said, like a tick on the back of an elephant, not even going to feel it. So we can throw that out to see where the y values are going. So we get to see a pattern if we do that. We also get to throw out that positive 2. So we can simplify our fraction for the sole purpose of really figuring out where are the y values going. And so when we simplify things a little bit, let's go ahead and rewrite it to clarify a little bit. Okay, to uncover what we need to uncover. So we have a 4x up on top, and we have a radical 3x squared. Radical 3x squared down here on the bottom. Okay, well, if you remember your properties of radicals, we can rewrite that. I'm going to do this a little piece by piece here. 4x, and then we have the square root of product would be the product of the square roots. Okay. Now, we know that the square root of x squared, you got to be really, really careful here, because the square root of x squared, this guy right here, is going to end up to be a positive number. Okay. So you just have to watch that, because even though x is approaching negative infinity, x squared is going to be positive, so you got to be really careful. So what you may have learned somewhere along the way is that the square root of x squared is not necessarily just x. It's actually the absolute value of x. Okay, so we're going to treat this just like we talked about possibly in class. Okay, it's showing every little step here. 4x, when x is going to be a negative number, we know we can take away those absolute value bars if we just put, well, let me put that bar in there, if we just replace the bars and that x with the opposite of x. Okay, so that's one of those kind of seldomly remembered concepts that you just need to remember, that when you take the bars away, you can do that for free. If what's inside is going to be negative, then just put a minus sign in front of it. If what's inside is positive, then you leave it alone. You don't change anything. The absolute value of x being positive is the same as just x. But in this case, x is going to be a negative number. So we have to put minus x there. Okay? Which means now we can go ahead and cancel those x's, and all you get is 4 over negative radical 3. Which, if you really want to clean that up a little bit, if you rationalize that denominator, you get negative 4 radical 3 over 3. Okay, and that is your limit. Probably one of the most challenging, but the more often you do those kinds of problems here, those kinds of limit problems that have radicals in them, the more you get comfortable with what you have to do in that case. Okay, as I look at number 26, as I'm talking about number 24 here, as I look at this problem here, I notice that it's almost identical to number 22. So if you look back at 22, you see we can cancel these guys out because those three terms are insignificant as x approaches infinity, insignificant compared to this term here. And as x approaches infinity and you raise all these big numbers to the 5th power, you can see hopefully that you're just going to get infinity. Okay, and then there's one more problem in this section. That's problem number 28. Just a moment. Okay, so number 28, we can see, wow, that looks a bit daunting, but I think we'll be okay here. We see x is approaching negative infinity, so let's simplify things even before we break up that cube root. Let's throw away the plus 4 and the plus 3, as we've talked about. We can also, once we do that, we can see, oh, we've got x squared over x squared. Well, those can be just canceled. And then we just get the cube root of 2 over 1 or just the cube root of 2. And so that's kind of a neat thing that looked like it was going to be a lot more difficult than it actually turned out to be. So we'll see you in the next video.